Now that we've talked about instantaneous rates of change, let's talk about how to interpret them graphically. Remember that we defined the derivative of a function f at a point A using this limit of ratios. This is the instantaneous rate of change of f at A. Let's look at a graph. Let's suppose that this is the graph of f, and let's plot a and a plus h on the x-axis and the corresponding points on the graph. Here's the line passing through those 2 points, and its slope, remember, is rise over run. This is the ratio that's used to define derivatives. This line is called a secant line. We can see that as we shrink h, the point on the right moves closer to the one on the left, and the secant line approaches this line. That's the tangent line. Its slope is the derivative of f at a. So we get the following definition. Suppose that f is a function that's differentiable at a. The tangent line of f at a is the line with slope equal to f prime of a that passes through the point a, f of a. It's usually most convenient to put tangent line equations in point-slope form, which in this case is this. Let's take a look at an example. Suppose that we want to find the tangent line of f of x equals x squared at x equals 5. We've already seen that f prime of 5 equals 10, which we determined using the definition of the derivative. Since f of 5 equals 25, the equation for the tangent line is y minus 25 equals 10 times x minus 5. You might wonder whether we can avoid using limits to define tangent lines. One common intuitive definition is that a tangent of a curve is a line that touches that curve at exactly one point and doesn't cross the curve at that point. Unfortunately, both of these can be false. Take this graph again as an example. If we draw this line, then it's tangent to the curve here, but it also intersects it over here. So you might think that you could say that the tangent line, at very least, touches the curve at only one point in a small interval around the point of tangency. But even that's false. As you might imagine, an example that doesn't satisfy that is impossible to graph accurately. I leave it to you to think about what such a graph must look like. I also leave it to you to think about how a tangent line can cross the curve at the point of tangency.